going to do, this is called inequalities in two triangles. We've actually done inequalities in one triangle before. Let me just review that very, very briefly. Probably about 2 class periods ago, we talked about this. Tell you what, let's do this. We always use an acute triangle, and let's go obtuse just to be different. I'm being different today, aren't I? Going white background, going obtuse triangle. I'm just wild and crazy today. I don't know what's going on. So let's see how we can do this. Let's label it ABC. This is just a review right here. This is not the 2 triangle thing. This is the 1 triangle, but I want to see you. I want you to see how the 2 triangle thing relates to the 1 triangle thing that we've already talked about. All right. So let's say this was like 120 degrees. Let's say this was, let's say that was about 40 degrees right there. So if this is 120 and this is 40, what would this one up here be, angle A? 20, right? Right, because that's 160. Take away from 180 is 20. We good with that? All right, so what did we ask you probably 2 lessons ago when you had something like this? What do you think they asked for? They asked you to compare some things, or they actually, if I could speak right, they actually asked you to put it in order from the smallest side to the largest side. Do you remember that lesson? It was only a couple days ago. All right, so I want to take this. I want to go from small to large. And they ask you to do both, right? The angles and the sides. Now, the angles are easy because they told you. Now, but let's do that anyway. What would the smallest angle here be? Anybody could do that. What's the smallest angle? Give me that letter. Give me the name of the angle. Angle A. Okay, what's the next one up? Angle what? C. And what's the largest one? Angle B. So if they said, list the angles and the sides in order from smallest to largest, this is the first part of it. Got it? And I actually had people in that lesson when I corrected the homeworks that only did like one or the other. But what did it say? It said the angles, what? And the sides. So why would people only write the angles down? I don't know. Why would people only write the sides down? I don't know. Because, well, I do know. Because they didn't read the instructions, right? Read the instructions, and it says list the angles and the sides. So there's the angles. But what we're really concerned about is the sides, okay? That was what we really learned about. So what would the smallest side be? Not just because you're looking at the triangle and you say, oh, it sure looks like it's the smallest side, but for 100% positive, and you used a theorem to do this, what would the smallest side be on this triangle? CB. Why? Give me a reason why. Just because it looks smaller than the other 2? Opposite the smallest angle, right? So if this is the smallest angle, look across from it or opposite the smallest angle, that's got to be the smallest side. So CB or BC. It doesn't matter how you write that one. Let's skip to the largest one. Let's not do the in-between one yet. Let's skip to the largest one. So what do you look for? If I want to find the largest side, what do I look for? I look for the largest angle, right? What is the largest angle? 120. What side is opposite 120? AC, right? Line segment AC. Everybody see that one? So this is the largest one. I'll put this. This is the largest side. This is the smallest side. And what else do we have? This is the, what do we usually say? Just middle. Is that right? Can't think of a better way to describe it. Can you think of another one? The in-between one? I don't know. The middle's good. All right, so this would be the middle side. So what do we put right here? AB. Or BA, doesn't make any difference. So that would be your answer. That's the angles from smallest to largest, and that's the sides from smallest to largest. Notice, I put a symbol in front of the angle, didn't I? And I put the line segment symbol on top of the letters, the line segment. And that tells me exactly what I have. I know just by looking at this that that has to be an angle, and that has to be a line segment. We good? That's all old stuff. That's pretty easy stuff, isn't it? What we're doing today is almost as easy. It's a little bit different. A little bit. Let's scooch that out of the way. It's a little bit different. So let me find. Let's do it. I'll just kind of make it look like the one in the book. I'm looking at page 367. If you want to follow along, you don't have to, but it's in there. So let's make one that looks like this. That kind of looks like that kind of looks like that. All right. And then, I'll tell you what I'm going to do. I'm going to copy that one, but watch what I'm going to do. If I can move it over, I'm going to tilt it just a little bit. So I just changed the angle of it, didn't I? And then let's take this one down here, copy and paste that. I'm not changing the value of these, am I? Did you notice? I just copied and pasted. We can keep it flat like that, I guess. I can grab these things. Come on, there it is. And put it right there. So notice what I have so far. I took this one, didn't I? And I copied and pasted it, so those two segments right there are exactly the same. Agreed? And then I took this one, I copied it, and I pasted it right here, so those two segments are the same. So what I'm going to do is I'm going to finish this up, make that a triangle right there. So what I want to do, now look at this angle right here and look at this angle right here. Let's just say this was like 47 degrees, and let's say this was like 28 degrees. Just making numbers up, okay? I don't know if it's exactly that, but it doesn't matter. Look what I have here. Now I have two triangles, don't I? I don't just have one triangle. And what was the title of this lesson? Inequalities in what? In two triangles. So here's the two triangles I'm talking about. And it said inequalities. Well, look what I have. First of all, I got one pair of equal sides, and then I have a second pair of equal sides. But look at the angle here, though. This angle is unequal to this angle right here. In fact, it's not just unequal. What is it? 47 is what compared to 28? What is it? It's bigger. It's bigger. It's greater. Okay, so 47 is greater than this. So what do you think we're going to do here? I'll just let you use your imagination here. Compare what we did before. Remember what we did before? We looked at the biggest angle, and it's across from the biggest side. Looked at the smallest angle, and it's across from the, what? Smallest side. But that was just with one triangle, wasn't it? That was only one triangle. But now we have two triangles, and I think what you're probably thinking is actually going to be true here. So look at this. I've got this side and this side equal to this side and this side. But the angle in between them, right, the included angle, you've heard that phrase before, haven't you? The included angle is not the same. What if they were the same? What if this was 47 degrees right here? What do you think might be true about the two triangles? Side what? Side angle side, that's right. And they would be congruent, wouldn't they? But do these triangles look congruent to each other? No, they don't. Why? Because the angles aren't the same. This is 47, this is 28, so these triangles are not the same. They're not congruent to each other. So they're unequal, okay, or uncongruent, I guess, if you want to say that word. But what do you think is true maybe about the opposite side? Look at this side opposite the 47, and look at this side opposite the 28. What do you think might be true about this side compared to this one? Let's quit saying this one and this one. Let's do this. A, B, C, D, E, F. What do you think might be true if I compare BC to EF? Which one's greater? BC is greater. Why do you think it's greater? Just because it looks like it's longer? It's not always the best way to do it. Because the angle, you got it. What's true about the angle? Explain it, Carol. Yeah, the angle opposite this side is bigger than the angle opposite this side, isn't it? So if I'm looking at this angle, I'm saying, oh, that's bigger than this. Guess what? The side opposite the bigger angle has to be bigger than the side opposite the smaller angle. It's really, really close to what we did before, isn't it? With that one triangle. But now we're taking a look at two triangles. But this has to be true. You have to have one pair of sides and a second pair of sides, and you have to have an angle in between. So now the book doesn't call it. I wish the book would call it this because I think this is really helpful. I'm going to call it this. We call it the side angle side inequality, and I think it's a theorem. Yes, theorem. Now the book doesn't call it the side angle side inequality. I've taught out of a couple different books before, in the past. And it seems like every book that I've ever looked at, they always call it the side angle side inequality theorem. This book, I'll show you what this book calls it. They call it the Hinge Theorem. And I'll show you why. Now, it's not a bad thing to call it the Hinge Theorem. I know exactly why they call it that, and I'll show you that in a second. But I really think, I kind of prefer learning this as side angle side, because what's going to happen? Look, the two sides are equal to each other, but what's the unequal thing? What's the unequal thing? It's the angle between them. Everybody see that? I've got one pair of equal sides, second pair of equal sides, but the angle between those two equal sides are unequal. They're not equal to each other. That means one's bigger than the other, right? Or one's smaller than the other. So look, if this is bigger than this one, this angle is bigger than this, then this side is greater than this. So what can I put here? I can put what? Greater than. And that would be your answer right there. Because they're going to ask you to compare two things. They're going to say, okay, compare BC to EF. So I put BC and EF right there, and I say, okay, what's true? Is BC bigger than EF, or is BC smaller than EF? Well, it's bigger. Why? Not just because it looks like it, but because it's opposite the larger angle. We getting this? You following along? Yeah. This side is opposite 47. This side is opposite 28. So BC has to be bigger or greater than EF. Not just because it looks like it. And I say that a lot, don't I? Because every once in a while, they're going to throw some triangles in there, and they're not going to be drawn to scale. I mean, this is kind of drawn to scale. That looks like it's bigger than that, doesn't it? BC looks like it's bigger than EF. But what if they would have made this 28 degrees and this 47 degrees? It wouldn't be drawn to scale, but you still have to go by the numbers. All right, you got to be careful with that, I'm telling you. So make sure you know how to work out the numbers here. You okay with that? Let's do this. Give me a second because I want to copy and paste. Did I grab that or not? I don't know if I did or not. No, I guess I did this. That's right. Let's connect it. That. Alright. Group it. Scooch that over here. I'm going to grab both triangles again. Same exact triangles. Might as well just use the same ones. And grab that one. Grab that one. Grab that one. There we go. Copy that. Paste it. Group it. You see what grouping does to it? I put Control G for group. Watch. If I just grab one of these sides, it moves the whole entire triangle because I grouped them all together. Watch this. If I ungroup it, Shift Control G, watch what happens. What do you think happens if I just grab this? It's just that one separate one. Everybody see that? So anyway, if you know, it's a fairly common thing in desktop publishing is that you select everything and you hit Control G and it groups it, and then I can take it and then just move the whole thing around. Alright, so that's kind of nice. Alright, just some nice little computer skills for you in case you ever use it somewhere. Alright, what do we name this, by the way? ABC, right? Was the A up here? I can't remember. So an A, then B up here, and then C here, and what, D, E, F? Did I go in the same order? Okay, I just can't remember. My memory's terrible. But you got it in your notes, right? All right, now watch what's given, though. The given stuff's a little different this time. Let's say, I can just make this up. Watch. They say that this, right, those were given, I believe, weren't they? But what did we do? We said that this angle A is unequal to this angle D. But this time we're going to be different. We're going to say that BC... and let's just put a number in here. Let's say BC is 12, and let's say EF is 9. Is that all right? Everybody with me so far? It's a little bit different information. I didn't say anything about A and D, did I? Okay, I told you that BC is 12 and EF is 9. So what do you think we're going to do here? We're going to make a comparison between angle A and angle D. Again, you might look at it and say, oh yeah, well, angle A looks bigger than angle D. But that's not exactly what we're going to do here. We're not just going to look at it. We're going to tell for sure. So this is not called the side angle side inequality because I don't know any angles, do I? What do you think they call this? Very good. It's called the side, side, side. It's not just side, 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 though. It's side, side, side what? Inequality. Because if you don't say inequality, that means all three sides are equal. What does this mean? This means two of the sides are equal, but one of the pair of sides are unequal. That's why it says inequality. You got it? And it doesn't matter if it's the side in between or whatever. But if you have two pair of sides equal to each other and the other pair of sides are not equal to each other, that's where this thing comes in. They also call it the converse of the Hinge Theorem. Well, I didn't tell you why it's called Hinge Theorem. Yeah, we'll do that in a second after this. So let's take a look. So if I have two pair of sides equal, but the third pair of sides are not equal to each other, what do you think I can say then? If this is bigger than 9, 12 is bigger than 9, what do you think that tells you about angle A? That's right. So it's a little different, right? It's slightly different. So I could say that angle A is greater than angle D. That's the converse of the I like to call it the side, side, side inequality. You won't see this in the book, side, side, side inequality. But other books you may, and I kind of like this way. All right? Does that help a little bit? Let's do a theorem. Or not a theorem, but an example. We are going to do that, but I want to make sure I get this example done first before I do that. So if we have time, we'll go back to that hinge thing. Let's go to this nice blue right here. See, now I can use these dark colors, which I wasn't able to use before. Let's draw this. So everybody should be drawing this, right? If I draw it up here, you should be drawing it. That looks like that. Okay, good. This is 65 degrees right there. This angle right here is 6x plus 15 degrees. They tell you this is 11, they tell you this is 9, and this is J, E, G, and H. Alright, that's everything. Oh, they tell you this. They tell you that that side is equal to that side. Alright, there you go. What we have to do is, it says, find the range of possible values of x. So I want to find what x can equal. What x can be equal to. Alright, to make this thing true right here. Well, let's see what we have. We don't know if this angle is bigger than this angle, do we? Not yet, do we? Do they tell you specifically that this is bigger than this? Do they? Come on, everybody look at it. Do they tell you that this angle is bigger than this, or this angle right here is bigger than this? No, they don't. So we don't know that. But we do know one pair of sides equal. Do we know any other pairs of sides equal to each other of these two triangles? Yes, you do. Look at it. Say it. I heard it. What'd you say? EH, right. EH is equal to EH, isn't it? So I do have a second pair of sides. So I've got one pair, I got two pair of sides. My third pair of sides I know are unequal because this is 11, this is 9. I know they're not equal to each other. So what does that say about these two angles right here? Look, if this is opposite 11 and this is opposite 65, which one of these is the biggest angle? 6s plus 15. How'd you know that? Because it's opposite the what? The bigger side. Getting the hang of this or not? All right, so this angle is opposite 11. This angle is opposite 9. Well, 11 is bigger than 9, obviously, so this angle, 6x plus 15, has to be bigger than 65. I'm liking this, aren't you? Pretty easy. So 6x plus 15 has to be greater than 65. Do you remember in Algebra 1 solving for these inequalities? You don't? Bet you did, though. It's just like an equal sign. Solve this just like it's an equal sign. There is an exception on this problem. We don't have to worry about the exception. So for right now, let's just solve this like it was a regular equal sign. What would we do? Subtract 15 from both sides, right? That cancels out. Bring down a 6x. Greater than 65 minus 15 is what? 50. Divide both sides by 6. And x is greater than 50 over 6. And I think that comes out to like 27.5 or something, if I remember right. I'm looking. Yeah. We'll say 27.5. So what are the range of values for x? X can be any number that's bigger than 27.5. Okay? Actually, you know what? Wait a minute. What does that come out to be? That doesn't come out to be 27.5. What am I doing? I looked at the wrong thing on my book. It's 8 point something. Oh, man, I said that in the last class. If anybody watches that on YouTube, they'll probably freak out because of what I wrote right there. It's 8 and something. It's 8 and a third. It's 8 and 1/3. Okay? Sorry about that. So x has to be greater than 8 and a third. Now, does that mean x can be like a million? Nah, because like 6 times a million is 6 million plus 15 is 6,000,015. Can you have an angle that's 6 million degrees? No, okay, it can't be bigger than 180, right? So that's the smallest it could be. But what we're going to do is this. We're going to say that, let's see what they do, just make sure I do this right. So we're going to say this, that 6x plus 15, now that can't be a straight line. It's not a straight line. Okay, you wouldn't have an angle out of it. It has to be less than 180 degrees. Maybe I'll explain this a little bit tomorrow. All right, so I have two things. This is part of it, and this is the other part of it. So it has to be less than 180 degrees. Would you agree that this angle right here can't be any bigger than 180 degrees? Right? Because 180 degrees would be a straight line, wouldn't it? So these two don't even make a straight line, so it has to be less than 180 degrees. So what do? We subtract 15 from both sides, and 6x is less than, what's that, 165? Divide by 6. This is that number I was looking at. So x has to be less than 27.5. Well, why did I put equals? X has to be less than 27.5. And there, that's your answer right there. So x can be any number between 8 and a third and 27 and a half. This is how you would write your answer. X is between 8 and a third and 27 and a half. All right? I can't show you that Hinge Theorem thing. That's okay. It's not that big of a deal. That would be how you write your answer. All right, let me give you a worksheet, and then you guys can go.